Picture this. It's the year 12,000. A research probe from some other world drifts into our solar system long after humanity is gone and finds Earth exactly as we left it. Cities intact, satellites still tracing dead orbits, a radio signal still playing on a loop nobody ever answered. The probe's crew, whatever they are, run the numbers on how long that signal has been broadcasting, and they ask the same question we're about to ask, just in reverse. Why didn't anyone answer? Of course, what I just told you is fiction. Nobody has found Earth's ruins because we're still here, still sending. But the question underneath that story isn't fiction at all, and I promise the real version involves a lot fewer dead cities and a lot more men in cardigans pointing radio dishes at the sky. It's 70 years old, and as far as I can tell, we still don't have a good answer for it. This is the story of the loudest silence in the universe, and of the two answers to it that most of us would honestly rather not choose between. The question has a name and a very ordinary origin. In the summer of 1950, the physicist Enrico Fermi was walking to lunch at Los Alamos with a few colleagues, half joking about flying saucers, when he stopped and asked something closer to arithmetic than science fiction. Where is everybody? He wasn't asking about ghosts or conspiracies. He was doing rough math in his head, the kind physicists do at lunch, and the math didn't add up. The galaxy is over 10 billion years old. Even at absurdly slow sublight travel, a single civilization with a few million years head start could have crossed the Milky Way and left a footprint everywhere in it. We should be surrounded by evidence. Instead, Fermi looked around at 1950 and found none. But you could excuse that. In 1950, we hadn't even confirmed that other stars had planets. Maybe Earth really was some kind of fluke. Except the data since then hasn't been kind to that excuse. In 1961, the astronomer Frank Drake wrote down an equation, not an answer, just a way of organizing the guesses for how many communicating civilizations should exist in the galaxy right now. Decades later, NASA's Kepler telescope started filling in some of those guesses with real numbers. In 2013, astronomers Eric Pettigura, Andrew Howard, and Jeff Marcy used Kepler's data to estimate that roughly 1 in every 5 sun-like stars hosts a planet close to Earth's size, sitting in that star's habitable zone. 1 in 5. Our galaxy holds somewhere around 200 billion stars. Even being conservative about how many of those are sun-like, that estimate points to billions of Earth-sized worlds sitting at the right temperature for liquid water. Billions of chances, spread across 10 billion years. So Fermi's lunchtime question isn't really about aliens. It's a math problem with a suspiciously empty answer key. And for the 60-odd years since, our main response has just been to listen harder. That listening has a starting point. In 1960, the same Frank Drake behind that equation pointed a radio telescope in Green Bank, West Virginia, at 2 nearby sun-like stars, Tau Ceti and Epsilon Eridani, and simply tuned in. He called it Project Ozma, after the ruler of Oz, a nod to a place that was hard to reach, but not impossible to imagine. For about 400 hours, the telescope listened for anything that looked artificial. It caught one promising blip early on, a passing military aircraft, not a signal. Ozma ended the way most of these stories end. Nothing that looked artificial, just an expensive, sincere silence. 14 years later, we tried the opposite approach. Instead of listening, we spoke first. In 1974, scientists at the Arecibo Observatory in Puerto Rico beamed a message toward a cluster of stars called M13, roughly 25,000 light-years away. It was a simple radio broadcast, encoded as a grid of ones and zeros describing our DNA, our solar system, and a crude sketch of a human being, transmitted for about 3 minutes. It was less a phone call than a message in a bottle thrown off the side of a very slow ship. If anyone out there answers, the reply won't arrive for at least 50,000 years round trip. We sent it anyway. But the closest we've come to an actual answer arrived by accident. On August 15, 1977, an astronomer named Jerry Eman was reviewing printouts from Ohio State University's Big Ear telescope when he found a 72-second burst of radio noise, far stronger than the background static around it, arriving from the direction of the constellation Sagittarius. He circled it in red pen and wrote one word in the margin: "Wow." To this day, that signal has never repeated, and nobody has ever ruled out or confirmed what caused it. Astronomers have pointed telescopes at that same patch of sky for decades since, hoping to catch it twice, because a signal that only happens once is scientifically almost worthless. Eventually, the listening stopped being occasional and became industrial. In 2015, the physicist Stephen Hawking and the billionaire Yuri Milner launched Breakthrough Listen, a $100 million 10-year commitment to scan the million stars closest to Earth, using some of the most sensitive radio and optical telescopes on the planet. It's the Ozma experiment, scaled up by a factor of roughly 1 million, running continuously, processing more data than any SETI project in history. As of this year, it has found exactly what Ozma found in 1960. An enormous amount of very clean data, and nothing in it that looks like somebody talking back. 65 years of listening, in other words, isn't a lack of effort. At some point, it starts looking like a result. In 1996, an economist and physicist named Robin Hanson looked at that result and asked a sharper question than Fermi had. Not just where is everybody, but what exactly is stopping them from getting here? Hanson called it the Great Filter, some barrier, somewhere in the long chain of steps between lifeless chemistry and a civilization capable of crossing interstellar space that's brutally hard to pass. Think of it less like a wall and more like a marathon with an unknown number of checkpoints along the course. Checkpoints you can't see coming, and the only way to find out where they are is by counting how many runners never make it to the next one. Nobody knows exactly where our checkpoints sit, and any answer here has to stay a guess, dressed up as a shortlist. Candidates include the origin of life itself, chemistry assembling into something that replicates, the jump from simple cells to complex ones, which on Earth alone took about 2 billion years, the leap to multicellular life, the evolution of real intelligence, and, last on the list, a civilization surviving its own technology long enough to leave its home planet for good. Which one of those 5 is the rare one? There's no way to say for certain. Hanson's question was never really about identifying it. It was about where it falls on that list, relative to us. So, which is it? Behind us, or still ahead? Both answers are uncomfortable, just in different ways. If the Great Filter sits behind us, if one of those 5 steps is the rare one, and we already survived it, whether that was the origin of life, or the jump to complex cells, or intelligence itself, then we are, by sheer numbers, close to alone. Rare may be irreplaceably rare. Every empty signal, in that version, reads almost like a compliment. But if the filter is still ahead of us, the math turns against us instead. It would mean every civilization that reaches roughly our stage, radio telescopes, spacecraft, the first blurry pictures of its own galaxy, runs into the same wall shortly afterward, whatever that wall is, and none of them make it through. The philosopher Nick Bostrom, who has spent much of his career studying exactly this kind of risk, has argued that in that scenario, every new technology powerful enough to reshape the world should probably worry us a little more than it excites us. Not because progress is bad, but because progress might be exactly what the filter is waiting for. I'll be honest about where I land. I don't think the silence is a compliment. I think it's a warning we've been too busy to read carefully. If I had to bet, I don't think the filter is behind us. I think it's still ahead, and the fact that we can sit here and ask the question out loud might be the closest thing to evidence we have that we haven't reached it yet. If that kind of question is the good kind of unsettling for you, that's exactly what the newsletter is for. Just the stuff I actually think is worth your time.